Now on an equation like this where it's complex, we can actually look at one side first. So we're going to start on the left side of the equal sign and combine, simplify everything we can. So over here on the left side, where would we start?
3 times 5x times -1.
Okay, so 3 times 5x,
15x.
15x, and 3 times -1,
-9.
-3, right? Then we have -2 times 3x is -6x, and -2 times 4, -8. Now we can combine 15 and -6 make what? 9x. Then -3 and -8, -11. Over to the other side. What do we do first there? Distribute the 5. 5 times 2x, 10x, and 5 times 35, or 5 times 7 is 35. And then we're going to distribute the 2. 2 times x, 2x, 2 times -3, -6, and we still have the +2. Then what? So 12x, 10x, and 2x make 12x. 35 minus 6 is 29, plus 2 is 31. And then we've got to get rid of one of the x's. There's an x on each side. Which one are we going to get rid of? The 9x. We subtract 9x. -11 equals. Now we have to subtract 9 from the 12x on the other side. 12x minus 9x is 3x. A positive 31. And then
Add 31. Or subtract that.
subtract 31. -11 minus 31 is
42.
-42 equals 3x. And then
Divide up with 3x.
divide by 3. -42 divided by 3. -14 equals x. What do you think? Better than a sharp stick in the eye?
Almost, not much.
Not much.
Still painful.
Okay.
So up there we have the 55. I still have the same answer, but we have the 35 plus the 2x minus 6 plus 2. Don't you do addition before subtraction?
Remember, addition and subtraction happen at the same time. They're on the same level of priority. So you go left to right. But this actually worked out.
My mistakes, because in one of the rules it said you have to add before you subtract or something.
No, order of operations, adding and subtracting both happen at the same time.
You just go left to right, correct?
You just have to go left to right. Yep.
Oh.
Now, in this case, you would get the same answer either way. It would still come out to 31 no matter what. But there are some cases where it does work out a little funny.
You just end up with a -4 there.
Yeah. Any other questions on this one? That one's kind of ugly. I wouldn't give you a lot of those on a test.
But you would give them to us.
I might put one out there to see how you do. Yeah. I gotta have a little fun.
You keep going or when you
Up here, Yeah,
Oh, it doesn't matter.
the key is to get it down to one digit with a variable and one digit without a variable on each side. So you get it to once you get it to this form. Go ahead.
Could you have done the 12? Could you have moved the 12 over to the 9 side, the 12x?
Yes, we could have subtracted the 12x. If we'd have subtracted the 12x, then we'd have a negative 3x minus 11 equals 31. And then we would have added the 11.
Yeah.
So then you'd have negative 3x equals 42. And then you divide by negative 3. X is still going to be negative 14. Yeah, it does. It works out either way.
Okay.
Usually we subtract the smaller one just so that we don't have to deal with a negative.
Oh, okay.
But here we were going to have to deal with negatives anyway. Okay, I want to look at an equation like this. We've done some of these with fractions in the equations. And the way we have solved them has been to just do this. Add 3/4, just like we would with any other equation. That's gone. We've got 2x equals 6.5 plus 3/4. I could find the common denominators and add them, but I'm just going to tell you that's 7 1/4. Again, you could use your calculator to add 6.5 plus 3/4, or you could write it off to the side and write this is 6 2/4 plus 3/4 and go ahead and do the addition. Now, what do we have to do next? Divide by 2. So x equals 7 1/4 divided by 2 is 3 5/8. Look familiar? Okay. So you turn it into 2 over 1 and make this into an improper fraction as well. Then you flip it over and multiply by 1 over 2 instead of 2 over, divided by 2 over 1. So any questions there so far? Well, in order to avoid working with the fractions, there are some processes we can do. For 2x minus 3/4 equals 6 1/2. I could find a least common denominator or least common multiple of all the fractions. So I look in here, what are my denominators? 2 and 4. What would be my least common denominator? You're thinking greatest common factor. Least common multiple is always either bigger than them or it's the largest number. Since 2 goes into 4, if I was adding 3/4 and 1/2, I'd have to change them into fourths, right? So here's what I'm going to do. I'm going to get rid of the fractions. And I'm going to get rid of the fractions by multiplying by that least common denominator. Now notice the parentheses are around the whole equation. Every term, every digit in this equation has to be multiplied by the 4. So 4 times 2x is 8x. 4 times a negative 3/4. Negative 3/4 times 4 over 1. The 4's cancel out. That's just a negative 3. Equals 6.5 times 4. Well, 6.5, 6 times 2 is 12, plus 1 is 13 over 2, times 4 over 1. 2 and 4 cross cancel to give me 1 and 2. 13 times 2 is 26. 1 times 1 is 1. So that's just 26. So we have 8x minus 3 equals 26. And yes, our next step would be to add the 3. 26 plus 3 is 29. And then we would divide by 8. Now, if we punched into the calculator 29 divided by 8, we're going to get 3.625. But remember, we can just think of that as a fraction. 29 eighths. To reduce that to a mixed numbers, division and remainder. 8 goes into 25 3 times. 3 times 8 is 24, so there's 5 left over. That is 3 5/8. Which is the same answer we got up above doing it as fractions. Now in this equation here, adding 3/4 to 6.5 isn't horribly difficult to do. It's not a real bad common denominator to find. So it's not, especially if you're using the calculator to help you out, it really isn't that bad to do this with the fractions in it. This least common denominator that I showed you here is to get rid of the fractions completely. We did problems like this next one here. X over 6 plus x over 8 equals 7. And one of the ways we solve this was to treat that as 1/6 x, treat this as 1/8 x equals 7, right? So then what do we have to do over here? Well, 1/8 x plus 1/6 x, right? 1/8 plus 1/6 of common denominator. This is going to be 4/24 x plus 3/24 x, which is 7/24 x equals 7. And we would solve that by doing what? It's 7/24 times x. We're going to divide by the 7/24. Or multiply by 24 over 7, right? So x equals 24. Well, there's another way we could have approached this. Rather than adding these two fractions together, we could have looked at this. What is the common denominator for 6 and 8? Least common denominator. 24. So I could multiply this whole equation by 24. 24 times x over 6. Well, 24 over 1 times x over 6. The 6 and 24 cross cancel, give me 1 and 4. So 4 times x, it's just 4x. (24 times x over 8). Well, 24 over 1 times x over 8. The 8 and 24 cross cancel, give me 1 and 3. They both divide by 8. So 3 times x is just 3x. Equals 24 times 7. 168. So now, all I got to do is combine what's 4x and 3x. 7x equals 168. And then divide by 7, which is 24, which is what we got before. So there, again, it might be easier to multiply by the 24 and get rid of the fractions. It might be easier just to work with the fractions. It's all depends on your point of view. there are going to be some equations that start to get a little easier to multiply out by the least common denominator. They might look like this. Well, the least common denominator here, there's only one denominator, which is 3. So I'm going to multiply out by the 3. Well, 3 times x over 3, the 3's will just cancel to make x. 3 times 2x, a positive 6x. Don't forget my equal sign. 3 times 21, 63. X and 6x make 7x. Good. So 7x equals 63. We divide by 7. Good. X equals 9. And we could test that out. 9 over 3 plus 2 times 9 equals 21. 9 over 3 is 3. 2 times 9 is 18. And yes, that does equal 21. Now, we could have made that 1/3 x plus 2x equals 21. Instead of x over 3, we treat it as 1/3 times x. And yes, 1/3 x plus 2x is 2 and 1/3 x equals 21. And we could divide by 2 and 1/3. 21 divided by 2 and 1/3 is 9. We're going to get the same answer either way. Now, I don't mind working with fractions. Since I don't mind working with fractions, for me, it doesn't bother me to do it like this. This here, multiplying by that greatest common denominator, it's just a shortcut, the way of making it simpler if the fractions really confuse you. Some people just freeze up when they see fractions in an equation like that. Now, with that said, there are times when we don't have a choice, where we must use a greatest common factor, or greatest common least common denominator, or least common multiple like that. For example, I might have something like this. This one's kind of a tough one, but why not? It only hurts for a little while, right? First thing we have to do here is find the least common denominator. For 15, 9, 6, and 30. Well, 15 is just 3 times 5. 9 is 3 times 3. 6 is 2 times 3. 30 is 2 times 3 times 5. Is there anything they have in common? They all have in common. They all have the 3 in common, don't they? I'm just going to circle it. Get it done with. So, this top one has a 5, right? Does this one have a 5? Nope, we're going to give it a 5. Does this one have a 5? Nope, we're going to give it a 5. Does this one has a 5, doesn't it? So the 5s are taken care of. Next we notice this one has a 3. The top one needs a 3. Does this one have an extra 3? Nope, it needs a 3. How about this one? That one needs a 3 too. So now they've all got that extra 3. Well, we still got a piece to work with. This 2. This one already has a 2, doesn't it? So this one needs a 2 and this one needs a 2. Now they all have the 2. So what we have here is 3 times 5 is 15, times 3 is 45, times 2 is 90. Now we're just going to, 90 is our least common multiple, our least common denominator. We're just going to double check to make sure the rest of these multiply up to 90 as well, to make sure we didn't do something wrong. 3 times 3 is 9, times 5 is 45, times 2 is 90. 2 times 3 is 6, times 5 is 30, times 3 is 90. 2 times 3 times 5 is 30, times 3 is 90. So 90 appears to be a unanimous decision. I'm just going to move this down a little bit so that I'm not crowded at all there. So we are going to multiply this whole equation by 90. So we've got 90 times the 4x plus 3 over 15. So I make it a 90 over 1. And I can cross cancel the 90 and the 15. Both divide by 15. So this is 1 and this is going to be 8. No, it's not going to be 8. It's going to be 6. So now what I have is just 6 times the 4x plus 3. 6 times 4x is 24x, and 6 times 3 is a positive 18. Now over here, this negative makes this confusing. This is a negative 1 times that, right? So I've got negative 1 times 90 over 1 times 2x minus 3 over 9. The negative 1 times 90 over x makes that a negative 90 over x, right? So now I can cross cancel. Negative 90 and 9 both divide by 9 to give me 1 and a negative 10. So that's negative 10 times 2x minus 3. Negative 10 times 2x is a negative 20x. Negative 10 times negative 3 is a positive 30. Now I'm at my equal sign, so equals. On the other side, I've got my 90. I get 90 over 1 times 6x plus 4 over 6. 90 and 6 both divide by 6 to give us 1 and 15. 15 times 6x, it's 90x. 15 times 4, 60. And finally, we've got the 90 times x over 30. So 90 over 1 times x over 30. So we got 30 and 90 cross cancel, give me 3 and 1. So 3 times x is just 3x. Now that was all kind of ugly, and to be honest, if you don't like to cross cancel fractions, it makes it even uglier. Because if you don't like to cross cancel fractions, what you end up doing here is you're going to do 90 times 4x, that's 360x, right? And 90 times 3 is 270. That's over 15. So now you got to do 360 divided by 15 is 24x. 270 divided by 15 is 18. So you've got to work with those really large numbers if you don't like to cross cancel. Well, down here, we're going to work on each side of the equal sign. On the left side, I can combine 24x and negative 20x make 4x. 18 and 30 make 48. On the right side, I've got 90x and 3x make 93x and plus 60. Now what? Subtract 4x. I could have subtracted the 93x, but I would have ended up with a negative And we try to avoid that. So we got 48 here. 93 minus 4 is 89x plus 60. And then we subtract the 60. Negative 12 equals 89x. And then divide by 89. You got to get rid of the stuff that's with the x. Well, so over here, all we're left with x. Negative 12 divided by 89 is just negative 12 over 89. As a fraction. What do you think? Ready to reach for the sharp stick now?
I'd rather have a sharp stick right now.
Rather for the sharp stick? I hear you.
I got knee surgery again.
Knee surgery?
Seriously, why does it stay a fraction?
Why does it stay a fraction? Well, because you can't divide that out. The negative 12 divided by 89 can't be divided out. So you could divide it and make a really ugly decimal out of it.
Yeah, 0.1348.
Yeah.
On and on.
Which, that's still a correct answer. It's just rounded off, so it's easiest just to leave it as negative 12 over 89 as a fraction. Because that's an exact number. Whatever you write down from that decimal is going to be a rounded number. In your notes, give that one a shot. See what you come up with. Okay, we'll rescue you here, see how it's going. What did you find for the least common denominator? 24 works. So now we're going to do 24. Make it 24 over 1 times the 5x minus 2 over 3. What do we do with that?
Cross cancel 24 and 3.
24 and a 3 would give me 1 and 8, right? So now 8 times 5x,
40x,
40x, and 8 times negative 2,
16.
negative 16. Good. Now we do the 24 times the 3x plus 1 over 4. So 24 over 1 times 3x plus 1 over 4.
Cross cancel.
Cross cancel the 24 and the 4, gives me 1 and 6. 6 times 3x,
18x.
positive 18x, and 6 times 1 is 6. So we got our equal sign. 24 times 2x minus 7 over 8, so 24 over 1, 2x minus 7 over 8. Cross cancel 8 and 24 gives us 1 and 3. 3 times 24, or 3 times 2x, 6x. 3 times negative 7, negative 21. And then we've got the 24 times, what do we have to be careful of here? The negative. So it should be a negative 1 times 24 over 1 times the 4x plus 1 over 6. So that's going to make that a negative 24 over 1. Yep. Cross cancel the 6 and negative 4 gives me, or negative 24 gives me 1 and negative 4 there. So negative 4 times 4x, negative 16x, and negative 4 times 1, negative 4. Now I'm going to combine on each side. On the left over here, I have 40x and 18x make 58x. Negative 16 and positive 6 is a negative 10. Very good. Any questions there so far? Okay. There's a lot of steps here. This takes a long time. On the right side, we've got 6x and negative 16x makes negative 10x. Good. Negative 21 and negative 4 make a negative 25. Now then, I would add the 10x, get rid of it. So we've got 68x minus 10 is negative 25. And then
Add 10.
we're going to add the 10. 68x equals a negative 15. And then divide by 68. X equals, well, negative 15 divided by 68 is negative 15 over 68. Anybody get negative 15 over 68? No?
I didn't do my cross canceling.
Okay. Well, and it does work if you don't do the cross canceling. It'll still work because you got 24 times 5x, that's 120x. 24 times negative 2 is a negative 48. Then you got to divide by 3. 120x divided by 3 is 40x. Negative 48 divided by 3 is negative 16. So you'll get the same amount. So you're just working with big numbers. And if you're using the calculator to help you with it, it's not terrible. Now we also might run into some where we absolutely have no choice but to apply that least common denominator, because they might look like this. What's new here? Yeah, the x is in the denominator. We cannot solve equations with x in the denominator. We have to get x out of that denominator. And to do that, we use a least common denominator. We've got x, 6, and 3x. Well, for the 6 and the 3, what's the least common denominator? 6. You're thinking greatest common factor again. So we're going to have to use the 6. For the variable, remember it is the largest power, which is just the x. So we're switching gears here. Remember, an hour ago when we were talking greatest common factor, it was the smaller of the numbers, and it was the smaller power of the variable. So this would have just been a 3 for greatest common factor. But now we're going the other way. We're looking at least common multiple, or least common denominator. So it's the larger number, and it's the larger power on the variable. So we are going to multiply this whole thing by 6x. Now this first one's not bad. 6x times 3 is 18x. 6x times 2 over x. Well, 6x over 1 times 2 over x. I could cross cancel the x's if I wanted to. Or I can do 6x times 2 is 12x. 1 times x is x. What's 12x divided by x? That's just 12. Good. Then we've got 6x times 5 sixths. 6x over 1 times 5 over 6. 6x times 5 is 30x. 1 times 6 is 6. I could have cross-canceled the 6's again, but I'm doing it the other way for some reason. 30x divided by 6. 5x. Now let the equal sign. 6x times 5 over 3x. So 6x over 1. 5 over 3x. I could cross-cancel the 3 and the x, actually. But I'm going to do 6x times 5 is 30x. 1 times 3x is 3x. 30 divided by 3 is 10. X divided by x is 0. Is gone, yeah. Yeah, you could have cross-canceled the x's and then divide by 3 gives me 1 and 2, which gives you the 10. Okay, now what? 18 and 5 make 23x. You got it. Plus 12 equals 10, and then subtract 12. 23x equals a negative 2. And then divide by 23. Remember, we got to get rid of what's with the x. So negative 2 divided by 23 is negative 2 over 23. So x is negative 2 23rds. Are we having fun yet? No. Yeah. This is a little bit stressful.
Right? Yeah.
Excessive use of the pause button?
Yes.
Yeah. Okay, so kind of talk me through this one.
We have to find the common multiple.
Okay, or least common multiple, or least common denominator.
We've got x and 5 and 2.
Okay, so for the numbers, it's going to be 10, and then for the variable, it'll be x. So 10x. You got it. So we're multiplying this whole thing by 10x. Now what?
10x times 4 is 40x.
Okay, 10x times 4 is 40x.
And 10x is 1.
Wait, that's so it's legible. There we go. 10x over 1 times the 6 over x. I'm just going to cancel out the x's. 10 times 6 is 60, right? What's next? 10x over 1 times 2 over 5. Now I'm going to cross cancel the 5 and the 10. Gives me 2 and 1. So 2x times 2 is 4x. Then we're at equals 10x over 1 times 3 over 2x. Come on. So I'm going to cancel out the x's. 10 and 2 divided by 2 to give me 5 and 1. 5 times 3 is 15. Perfect. We combine the 40x and the 4x to get 44x. We still have the positive 60. That's 15. And then subtract 60. 44x equals negative 45. And then
Divide by 44, which gives you negative 1 and 1/44.
here you go. Come on.
There.
Yep, that's exactly correct. We divide by 44. X equals negative 45 over 44. Or negative 1 and 1/44. Okay, the next type of equation we're going to look at looks something like this. Now, as we look at this, at first glance, we see the x squared in there. And that makes us panic a little bit. Because I showed you a little bit last hour about using equations with x squared in them where you have to factor them. Well, but before we would even try to factor this, we do need to simplify and combine what we can. We are subtracting here. So I've got my x squared minus 3x plus 7. I'm going to write this one. Where's the x squared going to go under? Under the x squared. The negative 4? Under the positive 7. And we are subtracting. This is subtraction. So 7 minus a negative 4. 7 positive 4 is a positive 11. Good. Negative 3x minus nothing is negative 3x. X squared minus x squared? Nothing. It's gone. Cancels out. It's 0. So I've got negative 3x plus 11 equals 7. Now I'm just going to subtract 11. Negative 3x equals negative 4. And then divide by a negative 3. So x equals negative 4 divided by negative 3. Careful, negative divided by negative is a positive 1 1/3. It's a positive 4/3, which is a positive 1 1/3. So here, even though we started out with the x squareds in there, they didn't play a factor in because they canceled out. We could have something like this. As always, we identify where our equal sign is first. And we see if there's anything we can simplify on either side. On the left side, is there anything we can simplify or combine? No. How about on the right side? No. There are variables on both sides of the equation, so we have to get rid of that. I'm going to start with the x squared. I'm going to get rid of this one by subtracting 7x squared. That'll make that go away. But what does that mean I have to do? Subtract the 7x squared from the other side. And I can only take it away from x squareds, right?
Right.
Well, that was 7x squared as well, so that one disappears.
Now you're left with negative 3x plus 11.
Perfect. So once again, the x squareds cancel out in the first step of the problem. Now to solve this equation, what would I do?
With the negative 3 and positive 2x.
Yep, I've still got an x on each side, so I have to get rid of one. Which one do you want to get rid of?
Let's get rid of the 2x.
Let's get rid of the 2x. Okay, normally I'd get rid of the negative 3 because it's smaller, but let's get rid of the 2 just for fun. So I got to subtract 2x here. Negative 3x minus 2x is negative 5x plus 11 equals negative 14. Then what?
Subtract 11.
Subtract 11. Negative 5x equals negative 14 minus 11 is negative 25, and then divided by negative 5. So that's gone. X equals negative 25 divided by negative 5 is positive 5. There's a new quiz due tonight. It's 11:59 p.m. And new homework due Thursday. I think you guys have suffered enough, so I'll let you guys have the last 20 minutes to get started on the quiz or the homework. The network will stay up till noon, so I can answer questions if anything comes up. If you want to start the quiz and see if there's any questions that come up, you can do that.
Isn't the quiz time though?
The quiz, you got 2 hours, yes. Okay.
Did you get our tests graded?
I have the tests graded for 2 places. I still need to finish up New Richmond's. So what I'll do is, for those of you in the classroom with me, I'll let you guys take them with you at the end of class. For the rest of you, I will email them out by 2 o'clock today. I'll have them in your WITC email. So you'll have your tests graded and back to you today. Just a breakdown. There will be 276 points possible after the test is in the book. I do still have to go back and update those quizzes that I extended time on. So 276 points total is what we're looking at. 80% of that is about 220. So 220 points is your 80% mark. That's what you're shooting for, to stay above that C, or C or above in this class. Remember, C minus in here, if it's required to take your next class, doesn't quite make it. Now remember that 220 points, that's after you do corrections on the test. So right now I have not had, remember 80% is considered that passing point, but if you had, let's say you had 60%, if you do your corrections, you get half your points back, that puts you at 80%. So as long as you're at a 60% or higher on the test, you're still in the clear. You're still okay for the test. Okay? And so far, I've graded 7 of the 10 tests. Nobody's under 60% yet. Okay, so like I said, if you want to go work on stuff, feel free. I'll be in here to answer questions. I will have all your tests back by 2 o'clock today.